Supercapacitors are also known as ultracapacitors. They are high value capacitors much above the usual electrolytic capacitors which we use in our hobby electronics projects. As an example, the linear power supply of my VHF radio has 4 2000 microfarad capacitors. Supercapacitors have values in farads, as can be seen in the image showing a supercapacitor of 4 farad. For a record, 10,000 farad graphene supercapacitor created by SunVault Energy and Edison Power Company is considered the most powerful supercapacitor to date. Supercapacitors have high power density and fast energy discharge and recharge capabilities. Commercially available ones have energy density of 5 watt-hour per kilogram, while experimental graphene-based ones have energy density as high as 28.5 watt-hour per kilogram. This can be compared with the much lower energy density of an aluminum electrolytic capacitor, which is 0.01 to 0.3 watt-hour per kilogram. Though these energy densities are still lower compared to the 30 to 40 watt-hour per kilogram of conventional lead-acid battery and 100 to 265 watt-hour per kilogram of modern lithium-ion batteries, supercapacitors can be charged and discharged very much faster than batteries. Supercapacitors also have much more number of charge-recharge cycles than batteries. While supercapacitors can be charged in seconds or minutes, batteries generally take hours for charging. Millions of charge-recharge cycles are possible with supercapacitors, while it is only thousands for batteries. Supercapacitors can be used in applications which need rapid cycling and fast response, as in regenerative braking. Regenerative braking is an energy-conserving process in modern vehicles which recuperate the kinetic energy lost during braking to use later for starting the vehicle, which needs an initial high burst current. There are even buses and trams which run on supercapacitors with quick charging at scheduled stops and full charging at the terminus.